Welcome, I'm Liam, and I will be doing a lesson on primary, secondary, and tertiary alcohols and amines today. To start off, we have to do some review of the nomenclature of alcohols. Alcohols are hydroxyl groups that are attached to a carbon chain somewhere. As you can see here, there's your hydroxyl group connected to the carbon right here. Alcohols always end in -ol. Example can be ethanol or methanol. When naming the alcohol, always do your best to try to number the carbon chain so that the hydroxyl group is on the lowest possible number. And the longest chain is always the parent chain when naming. I now have some different types of alcohols, and I will slowly go through how to show you how to name them properly. Our first example is ethanol, and you want to identify the parent chain for it. You can tell that there's only two carbons, this being 1, this being 2 here. And since alcohol is on the end of the chain, it does not need to be specified where it is on its name. It's automatically put to the end, so it's just ethanol. Our second example has 4 carbons, 1, 2, 3, and 4. You can do it the opposite way as well, it doesn't matter for this one. And then you specify where your hydroxyl groups are, so it'd be 2 and 3 regardless which way you start at. And it's diol because you're specifying 2 hydroxyl groups. For the last example, you can see that it's an 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. You identify the side chains, so on 2 and 4 you have a methyl group. Also on carbon number 4, that is where your hydroxyl group is located. So it's 2,4-dimethyl 4-octanol. Looking at some properties of alcohols now. The hydroxyl group in the alcohol is a very polar bond, being hydrogen bonds. Other forces within the carbon chain would be London dispersion forces. Alcohols tend to be very soluble in water, but as the carbon chain increases, the solubility tends to decrease. Alcohols also tend to have higher melting and boiling points compared to similar alkanes, with most being liquids at room temperature. Another characteristic of alcohols, they are very flammable, and most are poisonous. We will now be looking at the primary, secondary, and tertiary alcohols. These are alcohols that tend to have different chemical structures. When naming these, you have to first locate where the hydroxyl group is. Then once that is found, look at the carbon it's directly attached to, and then how many carbons are attached to that carbon. So when looking at a primary alcohol, you see this hydroxyl group here is attached to 1 carbon, and then R represents a carbon chain. That carbon is only connected to 1 more carbon. Looking at secondary alcohols, here's your hydroxyl group, here's your carbon, but this carbon is now attached to 1, 2 carbon chains. That makes it a secondary alcohol. And then finally for your tertiary alcohol, here's your hydroxyl, your carbon, but this time it's connected to 1, 2, 3 carbon chains. All alcohols tend to have roughly the same sort of properties, but there is a slight difference when looking at primary, secondary, and tertiary alcohols. The boiling points of alcohols tend to decrease as the degree of the alcohol increases. This is because when the OH group is more exposed, it will be able to interact with other OH groups more, ultimately increasing the boiling point. For 1-butanol and 2-methyl 1-propanol over here, this 2-methyl 1-propanol tends to have a lower boiling point, even though they're both primary, because the chemical structure of 2-methyl-1-propanol right here compared to this one, this one here tends to cover more surface area, which means we'll react with more hydroxyl groups, being able to boiler faster compared to 1-butanol. Now if you want to take a minute and try to figure out which ones are primary, secondary, and tertiary alcohols out of the examples below, don't stress too much about the names, just try to figure out which degree of alcohol it is. For the first example, you can see that this hydroxyl group here, and it's one carbon here. This carbon here is then attached to 2 carbons, and that's it. So this would be a second degree alcohol. For the next example, hexanol, here's our hydroxyl group. There's the 1 carbon it's attached to. That carbon is now only attached to 1 other carbon, no more. So this would be a first degree alcohol here. Now for the third example, here's your hydroxyl. Here's your 1 carbon. Now this one has 1, 2, and 3 carbons attached to the 1 carbon in the middle there. Therefore, this would be a third degree alcohol. Now looking at the fourth example, there's your hydroxyl. There's your 1 carbon. And now this is only attached to 1 carbon right here. Even though it's a ring, this carbon is still only attached to the 1 carbon on the ring. Therefore, this one is a first degree alcohol. For our final example, we'll be looking at the hydroxyl group. There's your 1 carbon again in the middle. And then attached to that carbon you have 1, 2, and then your third carbon is right here. Therefore, for the final example, it's a third degree alcohol. We will now be looking at amines with a quick review. Amines contain an amino group. The suffix when naming them is amine. You don't need to specify the position of the amino group, but you do need to specify the carbon chains using N. The longest chain is always the parent chain. I will now be going more in depth how to properly name amines. First, you want to identify the parent chain. In the first example, this would be a propane. So it's a 3 carbon chain right here, 1, 2, 3. You then want to name the side chains starting with N's. In this case, you have 2 the same, so it's NN, and they're both ethyl groups, so it'd be an N diethyl. You then want to name the side chain on your parent chain and where it's located. So on the second carbon, you have a methyl group, so it'd be 2-methyl, and then you just want to name the parent chain at the end, so it'd be 1-propanamine. Now on the second example, you find your parent chain, which is a 4-carbon chain, 1, 2, 3, and 4. Then you name your other chains attached to the nitrogen. In this case, you have 2, which is an ethyl and a methyl, and you want to name it in alphabetical order. So you start with your ethyl, be N-ethyl, then N-methyl, then 1-butanamine. Now looking at some properties of amines, the carbon and nitrogen hydrogen bonds are polar bonds. The predominant forces within amines are hydrogen bonding and dipole-dipole. Other forces are London dispersion forces. Smaller amines tend to be very soluble in water, but as the carbon chain increases, the solubility decreases. They also have relatively low melting and boiling points. And smaller amines tend to have a smell like ammonia, but as the carbon chain gets bigger, they tend to have a more fishy smell to them. Now we'll be looking at primary, secondary, and tertiary amines. This depends on how many carbons are attached to the nitrogen. If there's 1 carbon, it's primary. If there's 2 carbons, it's secondary. If it's 3 carbons, it's tertiary. And if there's no carbons, as you can see here, it'd be ammonia. And you can tell with the primary amine, R would be the carbon there. There's only one. Secondary, there's two. And tertiary, all three are carbon chains here. Primary amines tend to have a higher boiling point because it can make bonds with each other as well as dispersion and dipole forces. Secondary amines still form hydrogen bonds, but having the nitrogen atom in the middle of the chain rather than at the end makes the permanent dipole on the molecule slightly less. Due to the lower dipole-dipole attractions, the boiling point is going to be lower. In tertiary amines, there is no hydrogen atoms connected directly to the nitrogen. That means there is no hydrogen bonding going on at all. This is why the boiling point is much lower compared to primary and secondary. The solubility for amines doesn't really depend on the degree of the amine. It really just depends how big the chain is for carbon. So here are some practice problems to attempt. Looking at the first one, you have your nitrogen here. It has one hydrogen attached to it and then two carbons to attach to it. Therefore, that would be a secondary amine. Second example, you have your nitrogen, then two hydrogens attached to it, and only one carbon attached to it. Therefore, that would be a primary amine. Your next example, here's your nitrogen, and your one hydrogen attached to it, and attached to that nitrogen you have two carbons attached to it. So this will then be again a secondary amine. For the final example, you have your nitrogen with 0 hydrogens attached to it and 1, 2, 3 carbons attached to it. So this would be a tertiary amine. This now concludes the lesson. You should be able to identify between primary, secondary, and tertiary alcohols as well as amines and be able to give some properties for each. Thank you.